So I would like to introduce our next speaker, which is Dr. Anastasia MYLONA. Thank you very much for being here. Dr. Anastasia MYLONA is a CIBSE technical director and is a charter engineer and a CIBSE member. She leads CIBSE's technical team and has served as CIBSE head of research for the past decade, and her contribution extends to advising the government on the implementation of Part O assessment of overheating risk in new dwellings in England, a component of building regulation. She studied architecture at the Aristotle University of Thessaloniki, Greece, followed by PhD studies at the World School of Architecture, and focusing on the environmental performance of buildings. Subsequently, she pursued postdoctoral research at the University of Oxford, exploring the impacts of climate change on the built environment. And her topic will be thermal comfort that changing climate. Exactly.
Thank you, Yoro. Thank you very much. If I knew you were going to read it, I would have done a briefer summary bio. Who is CIBSE? I thought this is an ASHRAE conference. It might be useful for me to introduce CIBSE in this audience. We are a very similar organization based in the UK. We are a membership organization, professional body. We have less members, 22,000 in the UK and internationally. And we, like ASHRAE, we are creating standards and technical knowledge for our members. One of our most recent publications, EMEA, provided a methodology for assessing a bore carbon of HVAC systems and MEP systems, and it has been adopted by ASHRAE as well as other regions for the US. And as Yoros mentioned in my bio, we are also working very closely with the government to inform policy. Am I too close? So I'm really sorry, I'm going to continue on the same doom and gloom that the previous presenter kind of started. I was in COP before I came to Athens, and you meet so many people from all over the world, and you realize that climate change impacts people and communities already massively. I know we had problems here in Greece, in Italy this year as well. So this is a very strong message. And this is in, again, a very similar kind of message with the previous presenter, that what this graph shows from the IPCC report, what it shows is that even if we stop our emissions tomorrow, we have committed already to a climate that is changing, at least until the middle of the century. Yes, so in a similar kind of note, this shows you the different emission scenarios, starting from a kind of low emission scenario to a high emission scenario globally. And 1.5 might seem to be a very small change in the temperature, but what it actually translates into, in terms of regional changes, is massive changes in temperature, extreme events, and as previously mentioned, flooding, and so on. In the UK, we're very privileged. We have, the Met Office is creating every few years the UK climate projections. What this provides the different sectors in the UK is with an understanding of how the climate is going to change based on the different emission scenarios and the global modeling that different countries is doing. So for the UK, we know that the winters are going to get warmer and wetter. I mean, we had a really wet winter last winter, and it continues. It just hasn't stopped raining. Hotter summers and overall higher temperature and more extreme events. So I thought I'll highlight the main impact on the built environment. And what this leads me to kind of highlight is that when we're talking about comfort, we are talking, especially in the UK, we're talking about heating. But this dynamic is going to change in the future. So we're going to have a different balance between heating and cooling. So in Greece, I'm Greek, we know how to deal with extreme heat, with hot summers. In the UK and Northern Europe and a lot of northern hemisphere countries, they're not used to that. So I always introduce the overheating risk with this slide. Yes, one of the issues is climate change is going to increase temperatures. But we also have the urban heat island effect. Our cities are getting bigger, and intense urbanization means that less green spaces. Everybody wants to live in the city center, right? We want to be close to work. We want to be where everything is happening. So we tend to want to live and have our homes and our workplaces in city center. It's too many of us, so our spaces become smaller. We still want the daylight, so we have big glazing on our windows. City center locations have increased pollution, increased noise, and of course COVID made everything even worse because now our homes are also our offices. Again, in Greece we know how to operate our shading devices, right? For many years, at least until I left for the UK, we didn't have air conditioning at home. We had shutters and we used cross ventilation in our homes, and that was enough. In the UK, it's difficult to introduce these kind of concepts to people because primarily we design for winter. So we want to have as less leakage as possible, as much daylight as possible, because in the winter, winter is gloomy. So these are the passive measures that we need to introduce in order to deal with the changes in the dynamic of heating and cooling. But research has shown us already that those passive measures will only be sufficient up to a certain point. After that, we will need to have some kind of a solution. And although I am technical director at CIBSE, I really want the industry to have the smallest impact. So if we can keep passive measures, perfect, but ultimately there are technologies out there that they're implemented. So we heard about heat pumps. In the UK, there is a huge incentive for homes to introduce heat pumps, but the problem is that they're just looking at heating. So what we are trying to say is that you need to think about the future. You need to think about how your cooling demand is going to increase in the future. So the heat pump that you are installing now, how is this going to evolve and change in order to cover your cooling demand in the future? So I thought I explain a little bit the kind of the design guidance that we offer our members to design for building adaptation for thermal comfort. So this might be familiar to most of you because ASHRAE is using the kind of the same standard of the adaptive comfort. The adaptive comfort is the idea that our physiology and we change our habitat as well based on an extended period of hot event. So if we had, so the first day, let's say a week of extreme heat, the first day will be really hot. The second day we will start putting lighter clothes, we're just gonna start opening our windows, change where we're going to work, where we're going to sleep. By the end of the week of similar temperature, we will still be hot, but perhaps not as hot as the first day. What this concept allows is that you have a set point that is changing based on the outdoor temperatures, and it allows more flexibility for your passive measures to be more effective and reduce the amount of energy you use. I mentioned the UK projections. I thought I'll talk a little bit more about that because it provides a series of products. They provide a lot of information, different variables, different weather variables for the UK, but also globally. So what at CIBSE, what we did is we took those projections and we created a set of tools. So the first one, which is the ProClip, is the graph on the right. It provides you with a visual representation of how temperatures are going to change. So for me, the key thing that I get from this graph is that if you look at the 2020s, so from 2010 to 2040, there is really very little we can do. Even in the 2050s, all emission scenarios provide us with a similar kind of range of changes in the temperature. Towards the end of the century, we see the biggest uncertainty, but the biggest changes based on the trajectory that we are now. The one on the left is the range of probability, because as engineers, we are used to designing for a single temperature or for a single metric. But with climate change, we don't know. There is a big uncertainty. So we need to get used to designing for variable scenarios. So we took those probabilities and we created a set of weather files. Again, the engineers in the room will be used to using tools like IES and TAS and Energy Plus and run weather files. So we have created a set of future weather files. So engineers can run the simulations for current climate, but also for future climate to look how their buildings, their designs are going to change into the future. So in the UK also, we have a new regulation. So the government has acknowledged the fact that what works now might not work in the future. So it recommends the use of the CIBSE methodologies and weather files to look at, for new homes, to look at how we can increase passive measures so we don't lose track of our decarbonization journey. So this is just an example of thermal comfort in different new homes when you're looking at the 2020s, which is 2010 to 2040, and you look how the different spaces, so and the different types of buildings respond to external temperatures. This is just for demonstration purposes. The next one is my last one. And the other thing, of course, that you can find out is how your energy dynamic is going to change. And you look here, this is a design project of offices. You look how the heating and the cooling, the red and the blue bits of the graph change. You start with high heating, and as the century goes by, that demand for heating is reducing, but the cooling is increasing. Again, a demonstration of the kind of analysis that you can do using future weather files. So, in summary, is just to highlight and reinforce the previous presenter's message that we need to increase the resilience of the climate change that we have already committed to, and that is for the next decades. We need to continue our decarbonization journey, but also adapt to the changes in climate. We need to make sure that passive measures are implemented and they can deal with the changing dynamic between heating and cooling, and where possible, adapt those buildings for the future with green technologies. Thank you very much.
Thank you very much, Dr. MYLONA. Very interesting presentation. Is there any question?
Yes, I have a short question to the beginning of your presentation. I'm coming from Switzerland, and I think the cold countries, they are even better prepared for the heat wave which is coming, because they are already insulated, they already have heat pumps which they can use reverse for cooling. As the buildings are insulated, they are already using low energy. So I think there, let's say the cold countries are quite well prepared already. What do you think about that?
So yes, and insulation is something that there is huge debate in the UK, you might know that. Insulation is great, it stops the heat from coming in, but if you have an extended period of heat events, and also you don't have shading, this heat is accumulated, so you need that kind of ventilation, either natural or mechanical, to exhaust the heat. So yes to insulation, but it needs to be understood that if heat accumulates, because it will eventually, then there needs to be a ventilation option. And shading, I don't know how northern countries are dealing with shading, and if shading is something that they regularly introduce into their buildings. It's a problem to convince people in the UK to have any kind of shading, in the external shading specifically, in their homes or in their buildings.
Yes, also just to remind that the evaluation is open, so you can start answering the first question. Just one question here.
Anastasia, I'd just like to comment about that last question too. So warm and humid climates and cold climates and heating environments, they're quite different from a building envelope perspective. And as we change, yes, you're better insulated, you're better prepared, and you already have heat pumps. I've been there, I've seen them. But when you get into these situations where we design an envelope quite differently in warm and humid climates than we do in cold climates, and especially with historic buildings, you never know where your drainage planes are, your vapor barriers and things like that, and you can get into situations, even if you've got a good building, where you've got indoor air quality, mold and mildew that begin popping up that you have to learn to deal with too. So, yeah, just something to think about.
Thank you. George, are we moving to the next question? Yeah. Okay, we'll move to the next one. Just one question from here.
Thank you very much. I would like to know which is the life cycle you are planning your buildings for, and which is the life cycle of the mechanical installations you are planning for.
I mean, you mean in the UK? For homes, they say about 80 years, but actually my home is 100 years old. So for other buildings, similar 60 to 80 years old life cycle. Sorry. For systems, as a rule of thumb, we're using a 20-year cycle.
So, since you're going to change after 20 years, why you have
to think about it? Because retrofit costs and also need space. So you need to know that you have both. You will have the money and the space to implement the new solutions, the new ductwork, whatever it is, the new systems.
Okay, thank you.
It's good to be the general chair, you know.
You do whatever you want.
Thank you, an excellent presentation.
Thank you.
Although the UK is not with Europe, ASHRAE has close ties, we have a presence
We are in
in the
spirit.
UK.
We are in spirit.
Yes. And before asking our president to tell us about more the association of ASHRAE and CIBSE, we are open and would like to have you as CIBSE and come closer to us. We have the expertise, and Dr. Balaz could be the contact point in giving you our perspective from a hot climate.
Yeah.
And Mr. President, would you like to tell us a little bit about the ASHRAE, CIBSE?
Go on, Dennis.
Yes.
Okay, well, I guess I understand how we're collaborating, right, and how we work together. So, yeah, it's a long relationship, and from at the executive level or the board level, we meet at least once a year, usually 3 times a year. Our summer and winter meetings, CIBSE comes to our meetings, and then at least once a year, and I just recently went to the CIBSE Graduate of the Year program and met with CIBSE. But the other thing is, through our Center of Excellence for Building Decarbonization, we're working together. And Anastasia mentioned that she probably has more details about how we're collaborating, but we have just taken their TM65 and brought it into the Center of Excellence for Building Decarb and adapted it for application in the North American climate zones and regions within the country. So again, there's no need amongst all of us when we're creating these standards to reinvent the wheel. We should take each other's work, try to improve upon it, and then pass it between each other and create the next zone. That's what it's going to take these transformative leaps of faith that the gentleman talked about this morning with his opening remarks. That we need to be taking giant steps forward at this point. So, yeah.
Thanks, Dennis.
Thank you very much.
Thank you. Thanks.
Well, just for